Today, we're going to crack the code of passive sign convention, so you can stop guessing and start calculating with 100% confidence. In this video today, we're going to understand the concept of electric power in such an easy way that you will never forget it. Students often make mistakes with a sign in power calculations, but today we will learn a rule that will save you from these mistakes forever. First, let's talk about what electric power actually is. In simple words, it tells us how fast electrical energy is being used or transferred. Its symbol is P, and we measure it in watts. Remember, power is not just energy. It is the rate of energy consumption. Power analysis is essential in electrical circuits because it helps us understand which element is absorbing energy and which element is supplying energy. Its basic formula is very simple. Power equals voltage current. A golden rule of circuit analysis is that the algebraic sum of power of all elements in any circuit is always zero. This means that the total power supplied by sources is equal to the total power absorbed by the elements. Now we come to the most important part, which is the passive sign convention rule. Understanding this rule is very important. If the current enters the positive terminal of an element, the power will be positive and that element will be absorbing power. But if the current enters the negative terminal, the power will be negative. Let's solve this with an example. So P1 is equal to voltage multiplied by current, and the power is equal to positive 54 watts because the current is entering the positive terminal, meaning it is absorbing power. For the second element, the current is entering the negative terminal. So the power is equal to negative 18 watts because the current is entering the negative terminal, meaning it is delivering power. Similarly, for the third element, the current is entering the negative terminal. So the power is equal to negative 36 watts, and this is also delivering power. When we add these three positive 54 watts, negative 18 watts, and negative 36 watts, the total power comes out to be 0 watts, which proves our rule. Now, let's look at a more detailed example to master this. In this circuit, we have 6 different elements. For P1, the current of 1 ampere enters the positive terminal of 16 volts. So P1 is equal to positive 16 watts, meaning it is absorbing power. For P2, the current of 1 ampere enters the positive terminal of 4 volts. So P2 is equal to positive 4 watts, meaning it is absorbing power. For P3, the current of 1 ampere enters the positive terminal of 12 volts. So P3 is equal to positive 12 watts, meaning it is absorbing power. For P4, the current of 2 amperes enters the positive terminal of 8 volts. So P4 is equal to positive 16 watts. For P5, notice here, the current of 3 amperes enters the negative terminal of 24 volts. So P5 is equal to negative 72 watts. For P6, the current of 2 amperes enters the positive terminal of 12 volts. So P6 is equal to positive 24 watts. If we calculate the total power, which is equal to 0 watts, this confirms that the energy supplied by one part is exactly balanced by the energy absorbed by the rest. Just remember which terminal the current is entering, and you will never make a mistake. I hope this topic is now crystal clear to you.